Okay, so this video is about nuclear fission and the process that's taking place with it. So when we're talking about nuclear fission, so fission means splitting. Okay, so fission is to split. So we're talking about the splitting of a nucleus. Okay, and in this case, we're going to look at the building of this fission and it leading with a chain reaction. So I'm going to use the example of uranium. Okay, so I'm going to look at uranium-235, which is commonly what can be used in nuclear power plants. And there is going to be a separate video about the nuclear power station, so I'm not going to go into that in this video. So what we have is a neutron being fired at a nucleus. Okay, so just remember I'm dealing with the nuclei here. I'm not dealing with the atom, so I'm dealing with the nucleus. So we call this neutron a thermal neutron. Okay, so it's called a thermal neutron because the neutron has to be going at the right speed. Okay, it can't be too slow so that it doesn't penetrate it, and it also can't be too fast so that it just goes completely straight through. You want it to be absorbed in this nuclei. Okay, so when the uranium-235 the neutron is absorbed within it, this creates an imbalance there. It makes it unstable. Okay, and this imbalance, so now we've gone from uranium-235 to uranium-236, it's become really imbalanced and it splits. Okay, and as it splits into two further nuclei. Okay, now this one here would be known as a parent nuclei. And the subsequent nuclei, so for example, uranium splits into barium and it splits into krypton, okay? Now these are known as daughter nuclei, and this essentially is waste, okay? We don't actually need these, and they're not really important for our subsequent kind of nuclear fissions. The other thing that is produced, as well as it's splitting and giving into these two daughter nuclei, is it also gives off three further neutrons. Okay, so it also gives off three other neutrons. Okay, apologies for saying electrons there. I meant to say neutron. And those neutrons can go on to cause further fission reactions. So those can cause further fission reactions. And again, we're not even really dealing with the most important bit right now. What actually happens as well is in this stage of when they split, okay, we actually have loads and loads and loads of energy being given off. Okay, so at this stage when they split, they give off the daughter, it splits into the daughter nuclei and gives me these extra neutrons, but we also release lots and lots of energy. Okay, and it's the energy that we harness to use in the nuclear power. Okay, so we also release energy. Okay, so when we're dealing with nuclear fission, we're often then going to be dealing with the fact that we want to have this energy, but we also want to sustain this energy, so we want these neutrons to cause further reactions. So I'm just going to kind of give you a really simplistic little diagram here. So let's take, we've got the blue, and the color coding here is going to be that the blue is going to be the uranium. Okay, the green, I'm going to just stick with being my barium. And I can't see the colours I've got there. I've got an orange, and my orange is my krypton. I'm going to use the red, just as I've done above, to represent a neutron. So I'm going to start my reaction. We've got lots and lots of lots and lots of uraniums in here. So I'm going to start with my neutron. My neutron is going to go in, okay, and it splits, okay, and causes those daughter nuclei. Remember, those are waste. Those are no longer being used, but it does release three further neutrons, and those neutrons are going to go on to cause three further fission reactions. So now I've got one, and now I've got three. Okay, those three are also then going to go and split. Okay, so my barium and my krypton, remember, those are not then involved, but it's going to give me three further neutrons to cause three further reactions. Again here, I'm going to three further neutrons to give me three further reactions. Again, three also then given from my last one down here. So you can see that each time it's getting bigger and bigger and bigger. So this time I've got 9 fission reactions just starting from my 1 over here. Again, each of those could go on to cause a further 3 each. So each time, if you think that I'm getting the energy here, all right, that's being released. All right, the next time, or the next round, I'm now getting 3 times that amount of energy, okay? And then in the third step, I'm now getting 9 times the amount of energy that's being released, okay, in the splitting of these reactions. Okay, and that keeps going up and up and up, and we call this a chain reaction. Okay, so a chain reaction means that the neutron from the previous reaction, from the previous fission, continue to cause further fission reactions. And essentially this is what's happening in a nuclear bomb. So essentially with a nuclear bomb we have that initial reaction, and that's why we end up with that mushroom cloud. We've got so many reactions happening that it's such a big expansion of energy that is being released. Okay, so just to recap, okay, in a fission reaction we have a thermal neutron. Remember, it has to be traveling at the right speed. It's not too slow, but it's not too fast. Okay, it's absorbed by our nuclei and it makes it unstable. It's unstable, and so it splits. And when it splits, it goes into 3 different things. We get our 2 daughter nuclei. We don't worry about those, they're no longer really useful. But we've got 3 extra neutrons that can go on to cause further fission reactions. And the most importantly, we also have a release of energy. Now, some of you might be thinking, where does that energy come from? That energy actually comes from something which is called a mass defect between these two. So if we actually added the mass up of these and the mass of those, they're actually a little bit different. But we do that at the diploma level rather than at middle school level. Okay, so for you guys, if you do want to know a little bit about it, ask me and I can go through it with you. If not, just knowing that it releases energy at this stage. And that is nuclear fission.